Hello, my friends. I hope you are doing well. Long time no see. Today I had a little bit time and I decided to talk about reinforcement learning. And it's always good to back to the concepts and the area of the AI. It's really good always to review the concepts and it can be really big help. That is the reason today I decided to talk about reinforcement learning. If you check my GitHub, you can find the repository with the name of Interactive Reinforcement Learning Playground. And there are a bunch of simulation here. I will talk about them. And I think that it can be a good review about reinforcement learning. I'm back to this GitHub repository, but first let me show you some simulation. The first simulation that I deployed on Hugging Face is Q-Learning simulation. If you check my Hugging Face account around 1367, there is a collection, the name is simulation plus RL, and there are a bunch of simulation here, and one of them is Q-Learning simulation. First of all, for people who are beginner, if you ask me what is the reinforcement learning, I tell you the reinforcement learning is a type of machine learning that agent or learner try to interact with an environment. So here you can consider this 5 multiple 5 grid word as an environment, and this blue circle is our robot or our learner. And there are some key concepts in reinforcement learning we need to know about them. One of them is environment, that I mentioned that. Another one is agent, that's our learner. And every of these cells or grid is our state. And the state means that the current situation of the agent. So, for example, if you consider an apartment, you can actually consider a big apartment as an environment, and every room in this apartment like a state. Okay, and there is another concept that is action, and action is choices the agent can make to move inside of this environment. For example, this learner can go left, right, up, down. So these are actions. There's another important concept that is policy, and policy is a strategy of the agent to select which action can be better. And it's not bad to mention that in machine learning we have some uh, value-based approach and policy-based. I will talk about the policy, but about the value-based, the Q-learning is a kind of the uh, value-based machine learning approach. It means that it uses Q values and Q table based on the Bellman equation, and it means that it try to find the optimized rewards. And if you ask me what is the reward, actually here we have positive and negative signals, and the agent try to learn based on these positive and negative signals. There are some obstacles here the agents try to learn and avoid to crush them, and actually the final goal is reached the goal. There are other concepts here about reinforcement learning, like learning rate, how quickly the agent incorporates new information, the exploration and exploitation concept. And exploration is chance of taking random actions. And maybe a more clear example is if you consider a word, and if in this word we have different kinds of uncertain place and certain place, exploration is actually how much we like to explore even the dangerous place, even the places that are unknown for us. But exploitation try to actually emphasize more on certain places and less danger places. And discount factor is important concept in deep learning. It means that how much future rewards matter for us. Okay, let's start the simulation. I just want to increase the animation speed because I don't like to spend a lot of time on this simulation. I just start learning, and you can see try to learn. And again, let's me increase the animation speed because I want to show you how this leaderboard change, and it will be update based on the new records that agent can make. And just keep an eye on these Q values, and you can see how the best passes will be highlighted with the blue color. So that is the concept of the Q-learning, and you can see, for example, here when the down is value of the 10, definitely it can be the action the robot, the agent can actually select and go to the goal, this cells, this state, okay? Or here, for example, the right side is 10, or here the right side is 8.9. So let me decrease animation speed a little bit, and you can see the agent how good can behave now. It actually learn based on the positive and negative rewards, and Q values here show how good this agent can find the path. Another example is about Q table. It's exactly like the previous simulation. It's exactly the Q-learning, but here I just use the Q table, and you can see it try to learn and learn more and find the best and optimal path. The next simulation I'd like to show you is airplane simulator that I made here, and just I started that, and you can see a few minutes ago with the maximum learning rate here and exploration rate and discount factor. And after 11 episodes, it tried to keep the balance here. Actually try to increase the speed and attitude, but keep the balance here and don't crash to the ground. And here actually the learning process will be recorded. And you know that you have access to all of these codes in the GitHub repository I will show you, but that's another experiment about simulator. Another concept I really like to talk about that is proximal policy optimization. Let me just reset the environment here. Okay, make it a little bit smaller. But the simulation demonstrates proximal policy optimization in reinforcement learning algorithm. And that's an important concept that use clipping mechanism. And if you ask me what is clipping, the clipping mechanism to prevent large policy updates, making training more stable, efficient, and definitely better performance. And this is the concept of the policy-based value. Actually, it doesn't use here the value-based concept. Use the policy-based, and that's the beauty of the proximal policy optimization. And let me show you how it works. I can place some obstacles here, for example, like this, and increase the animation speed. And the clip ratio is here important. Let me increase learning rate a little bit, and we can see here and check the terminal. Let's play that. Start training. So it tried to make the reward maximum, and it can actually learn very fast, and we can see the exploration rate and steps. But it's a really good policy. So this simulation demonstrates how agent learns to navigate to the goal using the PPO, and the main important difference between this one and the Q-learning was based on the concept. This one uses the policy-based approach, but in Q-learning we use the Q-table and the Q-value. And let me decrease a little bit the animation speed, and you can see how good our agent can find the way. Even I can actually add more obstacle here, and can actually consider, because the agent use the probabilities here and try to find the best way and avoid obstacles. And you can see how good it behaves. Even I can add another one here, make it harder for the agent. Let me increase and make them harder for this agent. try to find the best way, maybe a little bit increase the speed. And we can see it actually find the best way finally. Let's test it with the normal speed, and again, I'm sure it can find a way. There we go. And that's great. So it's about PPO. The next one I want to show you is self-driving car simulator that I made with React Tree Fiber. And you have access to the codes in my GitHub repository with the name of self-driving car simulator, React Apps Reinforcement Learning. That's the interesting one. And I used the React Tree Fiber to make this one with the help of the yarn. And here you can see there are some valves and there is a car, and this car try to reach the goal. There is a manual mode and AI mode for this one. I will show you. Let's see this one in the code. Yeah, this is the code, and I just wanna start that in the UI yarn start. Okay, here you can see the environment that is made by React Tree Fiber, and here we can actually change the learning rate, the gamma, the discount factor, how much the future rewards are matter. Even we can change the episodes here, decrease or increase. There's an AI mode and definitely human mode, and even we can track the Q table. Let's first try it with human mode. You can see actually we can rotate that, and it's a little bit strange here, but let's reset that again. So I can change it in different ways, but it's matter how AI can learn it good. For example, here, good. Okay, so let's go to the AI mode, reset everything, and start training. It will be a stock because it's just 100 episodes. It's crashed the valves. I just test that maybe after 30 minutes or 35 minutes, it can behave really good. It takes a lot of time, but finally it can find the goal, and after 3 or 4 seconds, it's find the goal very fast. So even I can stop that and make a little bit uh, increase in learning rate and start that again. You can see try to find the best way, and now it's trained more. But finally it can find the path, and actually just try that, and after 30 minutes or 25 minutes it easily find the goal. But first of all it tried to make a lot of mistakes, crash to the walls, but it will be finally arranged to the goal. Okay, and here you can see the Q table, and you can see how the values will be changed. We can turn right, left, right, accelerate, stop, and actually can make decision based on that. Maybe a little bit change here can be better, decrease the learning index a little bit. But that's all. That's all about these simulations, and you have access to my Hugging Face. You can check these applications, and if you back to the interactive RL playground here, there's a nice README file you can find about this simulation. First of all, the Q-Learning, and the Q-Table learning, and RL airplane simulator. You can learn about PPO simulation, the proximal policy optimization, and definitely after that you will be interested to study about reinforcement learning, considering human feedback. And there are some live demos here. Installation is really easy. You just need to clone the repository, and all of them are HTML. You just need to open the HTML and track with these simulations. There's a future projects. I will work on that. This is a React Three.js 5. I just mentioned that here, but it's not complete. Yes, but you can see here there are good visualization. I will work on that, still work on that, and it takes a little bit time to be complete. And it's not going to talk about the deep Q-learning. I just forgot to talk about that. Compared to Q-learning, deep Q-learning means that instead of using Q-table and Q-values, we use neural networks. The main difference is in Q-learning, we usually try to use Q-learning in simple solutions, simple problems, but deep Q-learning can be used in more complex problems like games. So that's all. That's all about Q-learning. I'm hoping that was useful for you. If it was useful for you and if you like that, please make a star on this repository, make like on this YouTube video. And thank you so much and hope to see you very soon. Bye bye.